All right, and the end goal is that we'll hopefully be able to get to the Bayes theorem that is in our IB formula packet. Okay, but we're going to start simple and build up to it. Okay, so the first thing that we're going to look at is we're going to look at a Venn diagram. Okay, now you guys have been doing Venn diagrams like this, right? Where we said this is A and this is B, right? And then we worked around that, okay? What we're going to do now is we're going to draw it slightly different, okay? Recognize that this had a section that was A, section that was B, it had an overlap, and then it had a section that was not A or B, right? So we're going to draw this slightly differently, though it's still going to represent the same thing. It's just going to be a little bit different visual. Okay, so we're still going to make our circle for A. Okay. But now what I'm going to do, instead of creating a circle for B, I'm going to create a section for B. So I'm just going to kind of cut this like this. Okay, so A is still the circle. B is this whole half over here on the left side of my rectangle. Okay, now can we correlate that to what we had before? We see we still have a section for A. We still have a section for B. We have a section for the overlap of A and B, which is this right here. And then we have a section out here that's not inside A, nor is it inside B. Okay, everybody all right with that visualization? Just looks a little bit different, but represents the same thing. Okay? So now what we want to do is we want to create a formula for the probability of A. Okay, so the probability of A, can you give me a couple of pieces that I need to add together to give me A? What pieces, sorry, not very clear there. There we go. What pieces can I add together to give me A? A is made up of two pieces, right? Okay, so what's this piece right here? That is A, but not B, or A and not B, right? It's the intersection of those two. So we're going to take the probability of A and not B. Okay, what else? What else do I need in order to get that probability of A? I need this other section. What's that other section? A and B, right? Now, I could go plus, but what is our mathematical symbol saying that I need to put those two together? This one, right? Sorry, that should be an N. A and B. Okay, everybody okay with that? Okay. Now, last class we learned, or 2 classes ago, we learned about the conditional statements. Okay, so conditional statements, remember, we said that the probability of A given B is equal to, and then what did we say that was equal to?
P, probability of A and B over probability of B.
Reading very clear. There we go. Okay. So A and B, this is in your formula packet, right? Over the probability of B, right? Now, if I rearrange that, then that means that the probability of A and B is equal to the probability of B times the probability of A given that B occurred. Okay, so I'm just doing some rearranging, doing a little bit of algebra. Remember, these are just numbers, they're fractions, so it's okay to do some algebra with them. Now, given this statement, how can I rewrite the statement that we made for A? Okay, we can now make the statement that the probability of A is equal to the probability of A and not B, which if we use this format, we can rewrite it slightly different, right? Because A and not B will be probability of not B times the probability of A given not B. Okay, so I'm going to rewrite that as the probability of not B times the probability of A given not B. Okay, so hopefully you can see the application of this formula to that. Okay, and now we're going to add on the probability of A and B. But the probability of A and B is probability of B times the probability of A given B.
Isn't it okay to change union to plus?
Yeah, in that case it was, right? They're mutually exclusive, right? Because the probability of A and not B has to be mutually exclusive with A and B. And because they're mutually exclusive, the union is equal to just the addition of their two probabilities. That's a very good question. And yes, I should have clarified that. Okay, everybody okay so far? Now, if you look at your formula for Bayes' theorem in your packet, does this look familiar at all?
Only the denominator.
It looks like the denominator, doesn't it? If you're looking at your packet, this looks very similar to the denominator. Okay? So that is the total probability that A could happen. All right? Now, it looks more complex, but sometimes the information that we have is given in this type of information. Okay? And so we'll look at some examples. All right? Right now, we will look at an example. Okay? So the example we're going to look at right now, given this situation, is we're going to say we have a computer factory. Okay? In the computer factory, there are, we're making mice for the computer. Okay, so we've got a factory. We're making computer mice. Okay, as the mice come off the assembly line, they get checked by one of two controllers. Okay? At random. Okay? Controller number one checks 55% of all of the mice. So what does that mean about controller number two?
It's 44%.
Okay, so controller number two checks 45% of all the mice. All right. The first controller, when it checks, it finds that 4% of the mice are defective. Okay, when number two checks, they find that 3% of the mice are defective. Okay, So now the question is, what is the probability that a mouse will be found defective by a controller? Okay. Now, there are a number of ways to do this. All right? And I will be the first to admit that if I saw a question like this, Bayes' theorem is probably not the first thing that would come to my mind. The first thing that would come to my mind is I would like to draw a tree diagram because I am a very visual, practical person. And I feel that by drawing a tree diagram, that I will be more successful in the end. If there's many parts to the question, maybe that's what I would do, is draw a tree diagram, try to fill in the blanks, okay? Now, there is a much easier way to do this, and that is because of the information that is given to me, I can use this theorem that we were just talking about, okay, the total sum of the probabilities. So what we're going to do is we are going to, for right now, define A as being a defective mouse. So that's what the question is asking. Find the probability that it's defective. So the probability that a mouse is defective is equal to, and then B is going to represent either checker 1 or checker 2. So B, a positive B, is going to be controller 1, checker 1. Not B is going to be checker 2. All right? Now with this, we actually have everything we need for this statement because we're going to go, the probability of defective is equal to the probability, what's not B? Controller 2. So what's the probability that it goes to controller 2? 45%. So I can put in 0.45 for that probability. Times the probability of A, and remember A represents defective, so the probability that it's defective given that it went to controller 2. So given that it went to controller 2, what's the probability? 3%. So we'll go times 0.03 plus the probability of B, and remember B was checker 1. What's the probability it goes to checker 1? 55, so 0.55 times the probability that it is A, defective, given that it went to controller 1, which is 4%, so 0.04. And so now you plug that in, you should be able to pull it right out. And what do you get? 0.035. Can I get 3 digits? 55, because IB always asks for 3 digits. Plus note that with 3.5, it's not clear whether I just averaged the two numbers together, the 0.3 and the 0.4, or if I actually did the correct calculation, which would lead to a slightly different answer. And that's also very common on IB exams, is you can get the, quote, right answer without using the correct process, and you won't get the points for it. Because it is very clearly incorrect to just take the 3% and the 4% and just average them together. Because it's more likely to go to the 4% controller.